Hi guys, this is day 5 video. So this is our last video for this week. And I would really like to hear some feedback from you guys. So when you have some time to write an email to me to tell me, I guess, how this week has gone. So how was this week? What was good or bad? Was it too much work? What can I do better to help you? And those things, you can think of other things to tell me, but those things will help me to kind of adjust what I will do for next week. And so today, like I said, we will be starting on a new chapter, chapter 9. We're going to start with section 1, and we're going to take just the first part, which is simplifying, multiplying, and dividing rational expressions. If you have a textbook, it's a page 553, so you can follow along the textbook explanation as well. Okay. So rational expressions are expressions that are in fraction. So if you think of fraction, but with variables, okay? So when we deal with fraction, what's important for you to remember is that denominator can never equal 0, okay? So we're gonna use this knowledge to try the first set of examples. So all this question wants you to do is to figure out what would make the denominator equal to 0, because this word undefined happens when your denominator is equal to 0, okay? So we said 12x is equal to 0. Then we know that x has to equal 0, because if you divide both sides by 12, then 0 divided by 12 is still 0. So x equals 0 is when this expression is undefined. And this one, number 2, it's the same. Even though the number is different, we know that if v is 0, then the whole thing's going to be 0, which means that it will be undefined. Number 3, 4, 5, and 6 is a little bit more complicated than just setting them equal to 0, because especially number 3 and number 6, it's a quadratic expression. That means you need to factor. So when you factor, you need to think about two numbers that multiplies to negative 21 but adds to 4. So it's 7 and 3, but one of them has to be negative and adds to 4, so 3 gets a negative. And because it's a leading coefficient of 1, I can just put the two numbers that I found in the parentheses. And that has to equal 0. And we solve this by looking at each parentheses in a separate way. So when is n plus 7 equal to 0, and when is n minus 3 equal to 0? So n plus 7 is equal to 0 when n is equal to negative 7. So this is one answer. And the other one is n minus 3 is equal to 0. So n is equal to 3. So there are two answers for number 3. Let's do 6 since it's very similar to number 3. So we need to factor two numbers that multiplies to negative 35 but adds to negative 2. So it's 7 times 5 would be 35, but 7 has to get negative. When you add them together, you need to get negative 2. So again, because it has a leading coefficient of 1, we put n's in each parentheses and put the numbers that we found right next to it. Again, we set them equal to 0, so n minus 7 equal to 0, so n is equal to 7, and n plus 5 is equal to 0, so n is equal to negative 5. So there are two values as well. Number 4 then is you set whatever is in the denominator equal to 0. So we solve n by subtracting 1. So n is equal to negative 1. Number 5 is very similar to number 4. So we set this equal to 0. And so we add 40 first. So then 25x is equal to 40. And divide both sides by 25. So x is equal to 8 over 5. And that's the answer for 5. Alright. The next question is actually simplifying. So on top, we were just finding out which value will make the expression undefined. But now we're actually going to simplify. Simplifying actually requires you to know greatest common factor. Because when you simplify the fraction, you always think about how many times 12 go into 6d, which is 5 times. And then x goes into x cubed, x squared times. So this one gets simplified to 5x squared. Okay? And this one, first of all, I can cross out 1, 0. And then 7 over 10, it's just 7 over 10. There's nothing you can do. But the v can cancel with 1v, so there's 1v left on the numerator and no v left for denominator. Again, this one, do you remember how we factored on above? It was n plus 7 and n minus 3. So once you factor, you can cancel out what's in the parentheses together. So you can't cancel out like m and m. Remember, you have to factor first and then cancel. And then you have 1 over n minus 3 as an answer. Number 4, you need to actually factor the top. 5 times 1 is 5, and 5 plus 1 is 6. So this factors out into n plus 1 and n plus 5. So then the n plus 1s can get canceled. So this just becomes n plus 5. This one, I know you just want to cross out all the 5s, but again, you need to factor first. So 35x and 35 has 35 in common. So then I factor out 35 and x minus 1 is left. 25 and 40 has 5 in common, and then 5x is left, and then 8 is left. Now, once you've factored both numerator and denominator, you can reduce. So it's 7x minus 1 on top, and 5x minus 8. And even though you might not like what you see here, this is the answer. Last one. This one is an important example because there is something you can't factor that you don't often think about is negative. So do you see how there's a negative in front of the leading coefficient? Leading coefficient is -1, right? In that case, we want to factor out negative first. And then we're going to think about two numbers that multiplies to 63 but adds to -16. And 63 is 7 times 9. And 7 times 9 does add up to 16 if both 7 and 9 are negative. So n minus 7 and minus 9 is on top. And then the bottom, it was n minus 7 and n plus 5 because we did this right before this example. And then you can cancel out n minus 7s, and then minus, right? Negative can stay in the top or in the middle, but make sure that you do have that negative there. So that's the answer for number 6. The next thing that we are going to learn about is how to divide and multiply the rational expressions. Let's do the multiplication first because multiplication is actually easier than division. So let's look at number 21. Even with the multiplication, your goal is to factor out what you can first and then multiply because you don't want to deal with foiling all the time. And 21 is another example that you're going to factor out negative. So some tip about when do I factor out negative. So do you see how that, let me just factor out 7, okay? if I factor out 7, it's become 4 minus b. And 4 minus b is very similar to b minus 4, but they are not the same, right? Because negative b and a positive b is not the same. So when you have the very similar expression, but only the sign is different, that's when you factor out negative. So this one, you should actually factor out negative 7, then it becomes negative 4 plus b, right? But in our commutative property, you can write it as b minus 4. So then this looks exactly same as this, then you can cancel them out. So then on top, there's only negative 7 left, and then the bottom, there's only b plus 10 left. So do you see how the multiplication wasn't all that complicated? Because we canceled out first, and then we multiplied. And that is the trick that you want to use. You don't want to just, for example, distribute. You want to make sure that if you can cancel something out after you factor. But number 22, fortunately, because these two expressions are exactly the same, I don't even have to factor. I can just cross them out because they're exactly identical. So then this just becomes 2 over 3 because 2 times 1 is 2 and 1 times 3 is 3. Last example, I do need to do some cleanup here. And again, it's not written in standard form because standard form will require x squared to be in front. So I'm going to factor out negative, and I will also rearrange so that it looks like what we are familiar with. Okay? So this is called standard form, from highest power to the lowest. And then I will factor this out. Two numbers that multiplies to negative 8 but adds to 7. It's plus 8 and negative 1. Because 8 times negative 1 is negative 8, and 8 minus 1 would be 7. And then it has x plus 8 in the bottom. I'm going to move a little bit. And then the other side is x plus 5. And I can factor out 9 from here. So you can kind of see the pattern, right? It kind of makes a question so that you can cancel things out a little nicely. So you can always cancel either cross, right? Or top and the bottom. So you can always cancel something from a numerator with something from the denominator. That's the only rule you need to follow. So then it's negative, don't forget about this negative, x plus 5 on top and 9 on the bottom. I will actually not go over the division because I want you to have enough time to actually digest this. So let me recap what we talked about. So first thing is that we always have to state which value that the rational expression cannot have, because since it's a fraction, denominator cannot equal 0. So this portion that we went over is actually quite important to understand and later graphing of this function. And then the second thing was the simplifying. We can simplify the numbers together, or and we can factor using factoring technique. We can get rid of the expressions itself. And I cannot overemphasize how important factoring is, because without factoring, you can't cancel things out. So the only time you can cancel things out is when there is no plus minus. Do you see number 1 and 2? 1 and 2, there is no plus minus like any other numbers. That's why factoring wasn't required. But as soon as you see plus minus, like all the other examples, you must go to factoring first. Don't do anything until you factor. And we looked at multiplication. Multiplication, you just multiply top with the top and the bottom with the bottom. But you can also cancel what's on the numerator with what's on the denominator. So that's why we can cancel out x plus 8 and x plus 8, but also x minus 1 and x minus 1, because this x minus 1 is in the numerator and this is in the denominator. So that's it for today, and I will go over the division tomorrow and complex fraction. I guess that will be on Sunday. And the homework is this, but actually don't do homework that involves division. So I think you should not do maybe number 9 and 7. So just do 1, 3, 5, and 25. Okay? I will see you tomorrow.